So hello everyone. In the last session we have seen some about electrostatics, and we have seen the Coulomb's law, and we have seen the basic properties of charge, what is charge, and then we have solved some numericals on the basis of Coulomb's law, and we have also understand the formula along with the some important points that is necessary for solving the questions. Clear? So now in today's class we are going to do some more examples, and then we will move to a most important topic, that is electric field. In starting you may feel that what sir is teaching, it's not so much important it's looking, but believe me, just be with me. I challenge you, after this complete, when the electrostatics complete, after that you can solve all the questions related to all concepts. That is my challenge to you. Okay, so shall we start? Because it take time to build a concept. Okay, it's not like that ki you can just in one day you can build the concept and you can create a something. It take time. Okay, so let's take one more question. So let us start. Okay, we are going to do some more examples. So let us suppose, let me use some space because some people commented that you have to please try to use the proper drawing and something like that. So let me do it properly. Okay, so let us suppose I hope everyone has joined. First of all, you tell me whether audio and video is visible or not, or it is clear or not. I hope audio and video is clear or visible. Let me check. Okay, so we will proceed. Yes. Yeah, so the question is, let us suppose there is a 1 Coulomb charge is here. Okay, there is at the origin, this is my origin, and at origin we have a 1 Coulomb charge is there. Okay, then at 1 meter we have 1 Coulomb charge, then 2 meters we have minus 2 Coulomb charge, like that. Okay, so it is like that. We have 3 meters, we have plus 3 Coulomb, then we have 4 meters, okay, minus 4 Coulomb, like that, and so on at infinity. You have to find the force due to all these charges which are placed on this axis on 1 Coulomb. You have to determine the force due to all the charges on this 1 Coulomb. You have to find the F net here. Okay, what is F net? That is my question. So just solve it. It's pure mathematics. So what you have to do for solving this? What is the approach you will see? What is F net? Simple. What is my F net? What is my F net? See, all the forces will be along this line only. Correct? This charge will repel, this charge will attract, like that. It will be go like that. Correct? This will be going like that only, because either the charges are positive or either the charges are negative. So I will use the vector form, correct? I will use the vector, or I will use the vector form directly. So what I will write? I will write K Q. Q is how much? 1 coulomb into 1 coulomb divided by 1 square, correct? Same manner, it will be minus K 1 coulomb 2 coulomb by 2 square, like that, so on up to infinity, correct? Now what is common from here? Common is K 1 coulomb. What you will left? 1 upon 1 square minus 2 upon 2 square plus 3 upon 3 square minus 4 upon 4 square, like that, so on, correct? This will left. So what you will get finally? You will get K into 1 coulomb, that is this thing. This you will get 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5, like that up to infinity, correct? This is my F net. This is my F net. Now how to add this thing? What is this? What is this? Is it AP, HP, GP? What is this? It is AP, HP, GP. What is this? So if you remember mass, ln 1 plus x, expansion is how much? Expansion of ln 1 plus x, it is x minus x square by 2 plus x cube by 3 and so on up to infinity. So just put x is equal to 1, you will get ln 2 is equal to how much? 1 minus 1 by 2 plus 1 by 3 minus 1 by 4, like that. And this is our required sequence. This is equal to how much? ln 2. So I will use this here directly. So what is my F net? F net will be equal to how much? That is equal to K ln 2. Answer Newton, correct? Simple mathematics. There is no physics is there. Only this is the physics. This whole is what? Mathematics. Simple. Only this much is the physics. This everything is mathematics. Clear? This is how, like, I am telling you how, what type of questions can come. I am framing the questions. Okay. Let's proceed further. I hope no one have a doubt. Okay. So let's proceed further. Let's take one more example. Let's take some good example. Okay. Like, okay. Let us suppose, okay, let us suppose, or question, let us suppose there is a one rod is there, okay. This is my rod, okay. This is a rod, clear? Okay. And suppose the question is, at a distance of A from the rod, there is a charge Q is there, okay. There is a charge Q is there, and the charge on this is lambda coulomb per meter. Charge density is lambda coulomb per meter. Now what is charge density? I hope you know that there are the lambda, sigma, rho. These three things are very important. Let me tell you, if anyone don't know, please understand this. This will come in moment of inertia, center of mass, everywhere it will come. So you have to familiar with this, okay. Okay. So let's see here, just for your sake of convenience I am telling, because this thing you face in center of mass, moment of inertia, like that. See, there are the three types of charge densities are there. I hope it is, I think it is not visible. Charge densities. Okay, we will go in very systematic manner, okay. So just be patient. We will go in very systematic manner. There are the three types of charge densities there. First, that is linear charge density. Linear charge density. Correct? Linear charge density. What do you mean by linear charge density? What do you mean by linear charge density? Linear charge density is defined as lambda, which is defined as, suppose there is a some rod or something is there. It is charge per unit length. Simple, you have to remember dq by dl. That is defined as, in definition, charge per unit length. That is my linear charge density. Clear? Okay. I don't think you have any doubt here. Okay, so then after that, okay, then after that we have what? Surface charge density. Surface charge density, that is defined as what is the definition for surface charge density? What is the definition for surface charge density? Surface charge density is defined as, that is sigma. See, unit if you want to write, you can write coulomb per meter here also, okay? Sigma is defined as what? Sigma is defined as, that is dq by dA. That is charge per unit area, that is defined as sigma. So charge per unit area. Clear? And this unit is coulomb per meter square. Correct? Similarly, we have also another type of density, that is called as a volume charge density. Okay, what is volume charge density? What do you mean by volume charge density? Can you tell me what do you mean by volume charge density? That is denoted as rho, which is equal to dq by dV, that is coulomb per meter cube. And what is the volume charge density? From here what we can write, that is charge per unit volume. Okay, so this is the different types of charge densities are there. Now you can see properly, I have written the formulas in a differential equation form, in derivatives form. Why? Because they are always valid anywhere. What type of geometry you are using, it doesn't matter, because we have to remember the general concepts which is going to be used anywhere. Okay, we don't stick to the particular formula. Now you can come here to this question. Why I have given lambda here? Because there is no area, here is the length is there. So charge per unit length is given, that is lambda. And you can see one more thing, this lambda is constant, means you can take anywhere on this rod any small element, because this is dx means small, dl or dx means what? Small element, small, very small. Okay, see, don't afraid from integration just make the things easy. Suppose this is my rod of length L, I am just breaking into a small length. Suppose so small. Suppose there are two students are there. I given to one student and ask her, okay, you just calculate the length of this rod. So what he will do or she will do, she just went and she cut this rod into small elements, okay, and suppose she has done 1000 pieces and then she measuring the length, and the person who is doing 10,000 pieces will measure the length. Suppose another student do a 10,000 pieces and also he or she is measuring the length. So obviously the student who is doing the 10,000 pieces will get the better result as compared to 1000 pieces. So that means from here what we understand, smaller is the element, more you will get the better result. So that's why we will use integration, because integration is a way of adding the things by breaking into a small, very small element, very small, almost tending to zero. So like here also. So what we will do, because it is the charge is uniformly distributed over the rod. So we cannot directly, can we directly apply the formula what we have learned, that is k q1 q2 by r square? Can we directly apply here? The answer is no, we can't apply. Why? Because if we want to apply the charge, that formula is valid only for the point charge, but here the charge is point charge. No, it is a distributed charge. So what we have to do? We have to break into a small point charge. So what we will do? We will use your concepts. What is the concept my saying? My concept will say, I will do one thing, I will take a small element. And one more thing, some people try to, like in center of mass we have learned, if there is something is not there, we just assume it will be on the center of mass and we just apply the things. But here it is not like that, because the relation is not linear. If you see the force k q1 q2 by x square or r square, it is a quadratic relation. So you cannot directly apply that thing. Clear? You cannot directly apply that thing. So that you sure? Now yes, just see how to find the electric or force at due to this charge, this rod over this charge. Simple. First what I will do, I will go at a distance x and take a small element. Okay, I will take a small element, that is dx from x distance. Correct? And suppose the length of the rod is given, that is obviously it has to be given, and that is L. Clear? Okay, so what is my lambda then? And suppose the charge on this small element is dq. So what is my lambda? Lambda will be dq by dx. Correct? So now we have a small element dq, and the distance between this is x and this is the point charge q. Now can we apply the formula here? Yes, because why we can apply the formula here? Because it is now we have as a point charge. So now what is the force? F net will be, or wait, we will not directly write F net because it is a small element na. So we will write a small force dF. Correct? What is that? That is k dq into q divided by x square. Now you just tell me, if I take the element here, or 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 take element here, whatever the element I will take, the direction of force will be changing or it will be remain same. If you see, for this element the direction of force is in this direction, for this element also the direction of force is in this direction, for this element also the direction of force is, so whatever the direction you will take, the direction of force will be always same. So from here we can say, sir, we can directly add it without any taking the component. Okay, so what we will do, we can directly go for the integration. Okay, now there is dq can be written as lambda dx, so you will get k lambda dx into q divided by x square integration. Now what is the limit for x? Now you have to tell me what is the limit. See, x, if you see here, the what is the value of x? 0. Okay, here what is the value of x? A. Here what is the value of x? A plus L. So we have to go from 0 to a plus L or a to a plus L. That is the important thing. We have to go from 0 to a or a to a plus L. 0 to a plus L or a to a plus L, because the rod is up to here only, there is no rod and we are breaking the rod into the elements. So we will put the limit from a to what? A plus L. Now you just do the integration. That is very simple integration. What is k lambda q by x square is minus 1 by x. So minus 1 by x, you will put the limit. So lower limit minus upper limit. So it will become 1 by a upon 1 upon a plus l. That is my f net. Clear? If you remember this formula, that is also good. If you don't remember this formula, then you should remember. See, you have to remember whatever the formulas I am telling. You have to remember everything with proof, because in JEE Advanced you can't say what they will ask. They can ask anything. Clear? So this is my net force. You have to remember this. If someone asks you at night 2 o'clock, you have to tell the formula kq lambda into 1 upon a minus 1 upon a plus l, like that. You can speak. Okay? Clear? Here any doubt is there? So this is the force due to a uniform charge rod having a charge density lambda on a point charge q. Clear? Okay, we can proceed forward. Okay. Okay, so let's take one more question. It's very simple only. Or if you want, I can move forward, but I want to give you enough practice. I want to show you that what type of questions they can ask. These all are standard questions. If you go to any coaching, they will solve all these questions, and we are also doing the same. So we will also solve all the types of question for you. Okay, we will not leave any question which a coaching institute is doing and we are not doing. Clear? Suppose this is a hemisphere. Clear? Suppose this is a not hemisphere, a ring. Suppose it is a ring. Okay, this is a ring. Sorry. Suppose this is a suppose this is a ring of radius r. Okay, and there is a charge density will be lambda. Why? Because it is a ring, so charge will be present only on the where on the length only. So that's why. Now suppose there is a point charge is kept at the center. This is my point charge q. You have to find f net at q. Clear? What is the f net at q? Solve it. First of all, tell me whether you will take lambda, sigma or rho. It is given. So what is how to take the element in the ring? Because that you should know. If you have learned center of mass, if you know moment of inertia, then you should know how to take the element for a ring. How to take the element in the ring? Can anyone tell me how to take the element in a ring? How to take the element in the ring? Can please anyone tell me how we take the element in a ring? So we take the element in the ring in the form of r and d theta. Remember, r d theta. So what we will do? We will do one thing. Let's see the solution. How to find the force. So this is the case. What we will do? We will do one thing. This is my radius is r. So we go from theta, from some angle theta, we will take a small element, that is d theta. Correct? From theta we will take a small element, that is d theta. So what is this? What is this value? This value will be how much? What is that is small length? Can anyone tell me? What is that small length? Theta is equal to r into radius. So you will get r d theta. Correct? Now just apply the same concept. Now you know everything. Now you know everything. What is this? Okay, dq. So this is my dq. Smaller like charge on this element is dq. How to solve it? Simple approach. Just let me draw here a reference for you, so that okay, that will be easy for you to understand. Suppose this is the reference. Okay, so let's see here. Now you can see properly, there is a 1 point charge q is there, and there is another charge which is at distance r, and this is dq, and the angle is theta. Now can you tell me what is the direction of force? The direction of force will be like this, correct? This will be how much? Df, correct? This will be df. If this angle is theta, what will be this angle? This angle will be also theta. So what is this force? This force will become df cos theta. This all things I told you in the vector. If you are not able to understand, just go and see the lectures of vector. Okay, df sin theta, correct? Now you tell me, if I take the see here I have taken this element in this direction. If I take the element in this direction, you will get the force here, so you will get cos theta and sin theta. So can I say this horizontal component will be cancelled out? If I take this component here, okay, if you are not able to understand like that also, we will see that horizontal component, this df cos theta will become automatically 0. We will see that. Let us just follow the steps what are there. So first we have to write the df. Now what is df? Can you tell me? Yes sir, df will be sir k q dq by r square. Okay sir. What is then dq sir? dq will be sir, it's very simple. dq will be what? Because we know lambda is given, so dq is what? dq is sir simply defined as lambda into this length. This length is what? Sir, r d theta. Okay sir. So this is r d theta. So I will put it here. You will get kq dq is lambda r d theta divided by r square. Correct? This r square will be cancelled out. So you will get kq lambda d theta by r. So this is our df. Now we have to, as here you can see we are getting two components, so we can now we cannot directly integrate. What we have to do? First we have to take the another one case, and then we have to take the another case, and then we have to integrate, because here we are getting two components. So let's see. Okay, so let us start. The first is f. What is this? Let us say this is as f parallel, and this is f perpendicular, or you can say f horizontal and f vertical. Okay, so let us, this is f horizontal, that will be df cos theta. So it is integration of df cos theta d theta. Now what is integration? The integration, now you tell me the limit of theta from 0 to pi. Sorry, from 0 to pi. So that is from 0 to pi. What is my df? Df value is this. So kq lambda d theta cos theta, okay, divided by r. Clear? This is my f horizontal. So f horizontal will become how much? Just you take all the constant aside, so you will get lambda upon r into cos theta, that is integration from 0 to pi into detail. So what is the integration of cos theta between 0 to pi? Integration of cos theta is minus sin theta or sin theta? It is sin theta, and sin 0 is 0, and sin pi is also 0. So this value will become 0. And I have told you this horizontal component will automatically come 0, and now whatever we have learned, we have done, we are getting correct result. That means now let us take f vertical. So f vertical will be what? Integration of df sin theta d theta. Now what is df? Df is kq lambda d theta by r. Okay, kq lambda by r into d theta r lambda into d theta. So that will be sin theta d theta, integration from 0 to pi, same limit. So from here if you do, see what is the integration of sin theta? Cos theta. Cos 0 is 1, cos pi is minus 1, so this will become 2. So what is the value we will get? You will get 2k q lambda by r in minus j cap. Correct? Yes, so this is the results. You have, if you want, you can remember. If you don't want, you don't want, no need to remember. But this is the answer. So you will get only the vertical, or it is obvious because all the charge will try to pull this small charge in the downward direction. Clear? Any doubt? So this is the one example. Okay? Any doubt till here? If anyone have a doubt, please tell. Or we will proceed to the next topic. If you want to do some more question, you can tell me, otherwise we will proceed to the next topic. Okay, so our next topic now is started. So here, till here, what we have seen the properties of charge, we have seen the Coulomb's law, and we have also seen the some numericals, and we have built a one concept. See, Coulomb's, if you talk about electrostatic, the electrostatic is very small. Now the other things are your basic kinematics and the basic mathematics, how much you know. That is going to solve the question. Physics is that much only. The physics is only that much. Physics is not very big, but it is depend upon how you much know the things. Okay, so that's what I am saying. The concept will build from the beginning. You have to do hard work regularly. Now the next thing we are going to start, next topic is equilibrium. Okay. See, I also want, I can bring PPT to you and do everything just by this, but I don't want, because I want you to write everything with me. Then you will understand the thing, how the things are deriving, how we are doing each and everything. Okay. Clear? So equilibrium of charges. Let me ask you one simple question. Okay. It's very simple. Just let's see. This is my, suppose this is there. Okay. This charge is suppose Q and this charge is 4Q. Okay. And they both are fixed. They both are fixed, obviously. And the distance between them is L. Now you tell me, I want to keep another charge Q such that the net force on that charge will be 0. Where, let me write the question, where I should place another charge Q. It is positive only. When nothing is mentioned, just take it as positive, so that F net on Q is 0. Clear? That is what you have to do. So first tell me that where I should have to keep. Just use your common brain. Whether how many locations are there, whether they are 1 locations, 2 locations, 3 locations or multiple locations, where I have to place the charge. Just try to think and tell me where I should place the charge, whether they are 1 location, 2 location, 3 locations, 4 location or multiple location, infinite location. Where should I place the charge? Can anyone tell me? See, let us check. Can I place the charge here? If suppose the charge is here, this charge is going to repel the charge in this direction. This charge is also going to repel the charge in this direction. So the net force will be added. So here net force cannot be max 0. So that means this location is not possible. Here it is not possible. Okay. Can I place? So this is not possible. Okay, can I place here? Again it is same condition, so it is also not possible. That means only 1 location is there. Here only we can place the charge. We cannot place on the side. So here if I place the charge, this will repel the charge in this direction and this will repel the charge in this direction. So net force can become 0 here. So let us Let us treat that, suppose this distance is x and I have placed the charge capital Q here. I want to make the net force on this charge with 0. So what is the net force will be there? This will apply the force F1 here and this will apply the force F2 here. Net force I want to 0, so my F1 should be equal to F2. That means K capital Q small q divided by x square should be equal to how much? K capital Q into 4Q divided by how much? L minus x whole square, correct? So if you cancel out, how much you will get? You will get L minus x is equal to 2x. So from here you will get x is equal to how much? L by 3. So from where I have to keep the charge? I have to keep the charge at L by 3 distance. There you will get the net force is equal to 0. So suppose in the same manner, now I can ask you like that also. In the same manner, suppose I take one more example like this. This you can take for homework also, because that is simple only. What you can do? Suppose here I keep minus q and here I keep minus 16q. Same question. Where I should keep q? Where I should keep q so that F net will become 0. Same question. Same question. How to? What will be the position if this distance is L? What will be my position? You have to find. Suppose x is q. Here you are placing. You have to find what is my x. Same man. That you have to find whether I have to place in middle or here or here or here. Simple. What you will do? You will do the same approach. Okay. You will do the same approach and you will tell whether we have to keep so that my F net will become 0. Same approach, same manner. So from here can we do one conclusion? Yeah, we can put one conclusion. What is the conclusion we can draw from here? What is the conclusion we have got from here? Let us see. Sir, what is the conclusion? I didn't see any conclusion. Can you tell the conclusion? Yeah, I will tell you. There is a one conclusion we are getting. What is that conclusion? The conclusion is that if there are same nature of charge, then the charge Q have to place close to the have to place between the charge to get F net is equal to 0. Clear? This is the conclusion we are getting and this is the important concept. Okay, where here we have to place our charge so that we can get our net force is equal to 0. Clear? Any doubt? Okay, let's proceed further. Let's take one more example. Now suppose this is my minus q and this is plus 4q. Now if I ask you and suppose the distance is L, now you tell me where I have to place. Same question. Now I have changed the nature of the charge. Now you tell me where I have to place. Now you tell me where I have to place the charge so that I can get my F net is equal to 0. Now you tell me where I have to place the charge so that I will get my F net is equal to 0. Okay, now you tell me. So where we have to place the charge? Where we have to place the charge? We should place the charge where? So suppose if I am placing the charge here, this will repel in this direction and this will attract in this direction. So here F net can become 0. Yeah, we can place here, correct? If I place here, this will attract in this direction, this will repel in this direction, correct? So cannot become 0. So we cannot put into the middle, that is sure. We cannot place it in the middle. Okay, if I place here, this will attract in this direction and this will repel in this direction. That means here also can F net become 0. Now the question is where we have to place, whether we have to place here or here. So let us check. Answer is, or before going to, let's search for the logic. Suppose I place here, okay. Suppose I place here. I will erase this just for logic I am telling here. Suppose I place here. And suppose this distance is x. And due to this the force is F1 and due to this the force is F2. Clear? This is my case. Here if you see what will be the force, that is K. Due to this F2, what will be my F2? F2 will be K, Q capital Q by L plus X whole square, correct? And what is this F1? That is K capital Q 4Q by X square. It is obvious that this force is always greater than this force, because here the numerator and denominator, numerator is high, denominator is less. Here you can see numerator is also less and denominator is also high. So this force will be always less than this force. That is true. That is always true. So that means, is it possible to get a net force 0 here? Answer is no, we can't get. So that means we can't place the charge here. Clear? So where we can place the charge? Now the question is arises, sir, okay, we can't place here, then can you tell me where we can place the charge? Yes, answer we can tell. We can place the charge on that side. Then only we can get the net force is equal to 0. So let us suppose we have placed, this is my minus Q, this is my 4Q, this distance is L, and suppose I place it at X distance, this is my capital Q, and I want the net force to be 0. So I can write K capital Q small q by X square X square. So from here what you will get, L plus X is equal to 2x, correct? And from here we will get X is equal to L. That means we have to place the charge on this side, so at a distance of L. So can you tell some conclusion from here, like what is the another conclusion we are getting? What is the another conclusion we are getting? See, from here also we are getting one more conclusion. If you are able to understand, we are getting one more conclusion. What is that one more conclusion? Let us see. We are getting one more conclusion, and let us see that conclusion. What is that conclusion is saying? That conclusion is saying कि when there are similar charges, then placed charge at closer to the charge with lower magnitude on the opposite side. Clear? I hope it is visible to you. I think it is not. Clear? So this is the another one more concept. There's some people tell you the direct formula to calculate the distance, but I am telling you, you just follow the concept, you just check and just calculate where you have to place the charge. Till here, anyone have a doubt, please let me know. Then we will proceed further. Otherwise, we will proceed further. If anyone have a doubt. Clear? Any doubt is there? Okay, so let's proceed. Let me ask you one good question. Okay. Suppose what? Suppose suppose this is plus q and this is minus 16q, correct? I want to place a charge capital Q, okay, so that the net system is in equilibrium. Net system is in equilibrium. I am not asking that charge to be in equilibrium. I have changed the question. I want the net system to be in equilibrium. Means this charge is also in equilibrium, this charge is also in, that charge is also in equilibrium. And you have to tell me the Q value, nature and position, everything. Everything you have to tell me. Clear? Solve. Or let us do it as a homework question. That will be nice. Okay? Because this is a good question. So let us do it as a homework question. First you will try, then I will tell the solution. Tomorrow I will tell the solution. Okay? You have to find the magnitude, position and everything about that charge. Where we have to place, at what position we have to place, what is the value and what is the magnitude. Everything we have to calculate. Clear? Any doubt? Okay, let us proceed further. Okay, so our next topic is now stable and unstable equilibrium. Okay, because there are some of the question you will get in, because for NEET it is now finished. For NEET student, that much is only their thing, and now next few theory which I am going to tell here now, that is important. Now it is purely going for the JEE student. Okay, so let us see the some things. Okay, like they will give you some configuration and they will ask you whether it is a stable equilibrium or unstable equilibrium, and if it is a stable equilibrium then find the time period. If it is an unstable equilibrium then there is a no time period, because if you learn about SHM, in SHM we always, whenever it is a stable equilibrium, we will go for the finding the time period. So here we have to also do the same thing. Clear? Let's take one example first. See, if you see, I won't go very fast because I have to cover everything, so that if you want to prepare, you will get each and everything on one platform. There is no need to run here and there. Everything you will get here only. Okay, everything. Okay, all concept, whatever. Not a single concept I will lift. Not a single concept. Every concept, and in proper structure manner you will get. Okay. That is sure for physics. Okay, now let us see. Okay, so suppose there is a charge Q is there, capital charge Q is there, and there is another charge Q and mass m, and it is placed here. If I displace this charge by a small distance x, okay, in this direction, suppose x, it is stable or unstable equilibrium? You just tell me, it is stable or unstable? It is stable or unstable? It is stable or unstable equilibrium? If you know the basic, you can easily tell whether it is a stable or unstable equilibrium. Just a simple question. Just give me 1 minute. So it is a stable or unstable equilibrium? See what you have to do. How to check? You have to displace the charge in this direction. So this is my x direction, it is displaced. Okay. So here means the net force here is 0, it is in mean position. That means now I displace the charge here. Okay. So if I displace this charge here, this charge will try to repel the charge in this direction, and this charge will try to repel the charge in this direction. But as the distance decreases, this force will be more and this force will be less. So overall the charge move in this direction, correct or not? Because force is inversely proportional to distance now. So we can say it is a stable equilibrium, simple. A stable equilibrium. Clear? Simple. It's not so much tough, it's very easy. Just you have to analyze, use your simple brain. Okay? Simple brain. Not, you have to use your common sense. But sir, common sense is not so much common. Answer is yes, common sense is not so much common. That is true. Okay. Suppose now we have displaced the charge in this direction y. The displacement is not so much big, okay. This displacement are very small. Suppose this displacement is a small y is there in upward direction. Now you tell me whether it is a stable equilibrium or an unstable equilibrium. I am waiting for your comments, please tell. It is a stable equilibrium or unstable equilibrium? So what we will do, let us see. Simple approach we will apply. If we displace the charge in y direction, okay, let us see here. Suppose the charge is here. Now this will apply the force also in this direction. This charge will also apply the force in this direction. So you will get the node force in upward direction only, correct or not? In upward direction only. So whether the charge is returning to its mean position, answer is no sir. We have displaced it in the above direction and the charge is moving in the above direction only. It is not coming return back. So it is stable or unstable? So it is unstable. It is unstable. Unstable equilibrium. Okay sir. So sir, we have seen this is stable, this is unstable. So can we define time period for here? Yes. Then what is, then question is, what is the time period then? Can you calculate the time period? Then only we can know, we can say na, you know physics. Because knowing physics and understanding physics, these two are different things. Everyone say I know physics, but when it comes to understanding, then people say I don't know physics. Okay, so let us see here. We want to determine the time period. What is the steps we have to follow? We have to displace the charge slightly from its mean position, and then we have to write the F net. So what is my F net? So if I displace the charge in x direction here, so what is my F net? F net will be, that is k q square divided by, this is, suppose this distance is given as L and this is middle point, obviously if something is not, because at middle point only it will be in mean, it will be in stable equilibrium. Okay, so this is L by 2 plus x whole square minus k q square divided by, what is the distance from this charge? This will be, sorry, L by 2 minus x whole square, correct? And obviously this value will be negative, so I can write kq square, and if you will do, this will become L by 4 L square by 4 x square whole square, and this you will open, so it will become L square plus x square minus 2lx, and L square minus x square, so minus 2, this will become minus lx, correct? Okay, and x is very less than L, obviously, so we can write kq square, this is minus L x, this we can neglect, so it will become L square minus x square by 4, so this x will be neglected, so this will become L to the power 4 into 4 square, that is 16. So from here you will get minus k q square by L cube. Okay, this will be 16 into x, and that is my f net. So we got the kx form. So from here we know that time period is, what is the formula for time period? That is 2 pi root over of m by k. This k and this k are different, okay, they both are not same. So this is my k, correct? This is my k. So you will put here, so what is the time period you will get? Okay, what is the time period you will get? So my f net is how much? F net you are getting minus, what is that value? Minus kq square 16 by L cube. Okay, so minus kq square 16 L cube into x. So my time period will be how much? 2 pi root over of m upon, what is this value? This is k q square 16 into L cube. This is my time period, correct? This is my time period of the, this is my time period of oscillation of that charge. Clear? Any doubt? Clear? So what we have seen till now, we have seen some questions on different concepts. Till here what we have seen, we are just seeing the Coulomb's law only, and we are just seeing what are the different types of questions that can be framed by the simple Coulomb's law, and that is the different applications of the Coulomb's law you are getting. Okay? Okay? Just give me 1 minute. Clear? Yeah, clear? Any doubt? Okay, so let's proceed further. Yeah, so let us proceed further. And we will provide this note at the end of the chapter. When this chapter finishes, we will give you the notes also. All the notes will be given to you. Okay, but you have to write. Clear? So let us see some application with the pendulum also. Some of the applications with pendulum. अब application with pendulum. Okay, application with pendulum. Clear? Okay, so let us take one pendulum. Okay, suppose this angle is theta, this angle is also theta. Suppose here the charge q is there, here the charge q is there, and this is all in equilibrium. So can you write the equations? Yeah, so this will be mg, correct? There will be electrostatic force. What is the value? K q square upon how much? L sin theta, because this will be L cos theta. If this, suppose this length is L, then this will be L cos theta, L sin theta, so this will become 2L sin theta whole square, and this is my electrostatic force, this will be my tension. So if I draw like this, so this angle will be also theta, and this angle will be also theta. So from here you will get my what? T cos theta is equal to K q square into 2L sin theta whole square. T sin theta is equal to mg. So these are the two equations. Now if you see here properly, 1 2 3 4 5 variables are there. So they can give you any 3 variable and ask you any 2 variables. So just you remember, you know how to write the equation. Now I can frame any question with this. Suppose I put into the water, then I will apply buoyancy. Okay, I can do anything with this. Okay, I can do anything. Any case we can do just what. Okay, so let's take one example, one good question, and then we wind up. Okay, let's take one good question. Actually I have a fever, so my health is not little good, so that's maybe you are getting a lack of energy. Okay, clear? Okay, so suppose initially this is charge q, mass m, this is also charge q is there, mass m is there, length you take L, okay, L, and suppose this angle is 45 degree, this angle is also 45 degree, it is initially at equilibrium, this is a equilibrium condition. Okay, correct. Now suppose this angle will become 60 degree, correct? So if it is 60 degree, and suppose this charge is again here q, mass m, this charge is q, again mass m. So what will be going to be happen here? First you tell me what will happen. What will happen here? Okay, obviously initially the main position is as 45 degree. Now you bring it to 60 degree, so it will obviously come down. correct, like that. It will obviously come down like that, correct. From here it will come down like that. So it will come, then it will have some acceleration, and that will be tangential, correct, because it will do some circle like this. So it will have a tangential acceleration. You have to find this tangential acceleration in terms of g, in terms of g. Okay, I give you 1 minute, just try this, just try this once, because it is a very good question. Just try this, apply your all concepts, whatever you know, and try to solve it. You have to find the tangential acceleration in terms of g. If you know vector, if you know how to take the component, you can easily solve it. It is not, see, electrostatics is not going to stop you to solving any question. It is your basics, how much you know. Only vector will come into the picture, and some basic kinematics, that is come into the picture. If you have a strong that, then no question of electrostatics can stop you. See, I am taking that much of that many examples only because I want you to tell that simply I just want to tell you that the concepts are going to repeat, question is not going to repeat. So I want you to master the concept. If you can master the concept, then you can solve any question. It doesn't matter. Really, it doesn't matter what type of question is coming in front of you, whether it is Olympiad, JEE Main, Advanced, NEET, it doesn't matter. See, for NEET the syllabus is finished. For syllabus not, sorry, I slipped my tongue, not syllabus, exactly the portion. Wow, that much in NEET, that much not going to be asked. But yeah, we are covering everything, so we will cover everything. So these are the concepts are important for you, okay, and you have to fight with the questions. If you want to solve the good question, you have to fight, okay, you can't be ideal. So let us see this, okay, and you have to try after that. After I will solve, you have to try it at home by yourself also. Let us see. See, if in my front, if this question come in front of me, how I will think. Let's see how I will think. Okay, okay. So it is initially at equilibrium. So I will directly write. Okay, you remember we have this equations. T cos theta is equal to this, and T sin theta is equal to this. Correct. Okay. So this thing we have, and this I remember. If I am a good student, I know the thing. Then I will directly write my electrostatic force will be automatically equal to mg, because T cos theta and T sin theta both are equal, correct, because it is 45 degree. What is electrostatic force? K q square upon 2L sin 45. Sin 45 is root 2, so it is 2L square, correct. That is equal to mg. So from here I can write my kq square by L square is equal to 2mg. So from here you get kq square by L square is equal to 2mg, correct, this relation. Okay, now come to here in this picture. If I see, okay, let me do one thing, just move this thing to some point. Okay, clear? So you tell this will be MIMG, correct? Okay. Now what is the direction of electrostatic force? See, it will go like this, correct? Acceleration in this direction, correct? Yes or no? Just give me 1 minute. Acceleration in this direction. Okay. Yeah, this angle will be also 60 degree. correct? This is my electrostatic force Fe. This angle is also 60 degree, and we have to take the component along acceleration. Why? Because the particle is moving in this direction, so that means the net force in this direction. So that means you have to take the component in this direction. So what is the component in this direction we will get? You will get At is equal to F net divided by mass. What is F net? This is mg, this will be mg cos how much? Mg, this is 60, this will be 30. So that means mg cos 60 degree and mg sine. So this will be mg sine, sine 60 degree minus this force Fe cos and Fe sine. Okay, so Fe sine 60 degree, correct? M, this will become G sine 60. I will take common. This you can use from here, kq square by Fe is how much? What is the net force? That is net force you can write from here also, that is k q square 2l sine 60. Sine 60 means root 3 by 2, so this will become 3l square, and this can be written as how much? 2 by 3 mg, correct? This is my electrostatic force, so you can put it here. So you will get 2 by 3 mg divided by m into sine 60 degree. So G minus 2 by 3 into sine 60 degree. So this is how much? This will be sine 60 is root 3 by 2. So this will become G by 2 root 3. Correct or not? Root 3 by 2, 2 will cancel out. No, 1 by 3 root 3 by 2. Correct. 2 meter per second square. That is my tangential acceleration. Clear? Okay. So I hope you have liked the sessions, and we just want only one thing from you, that you do your preparation properly. Actually today my health is not good, so I am not able to take the class, because I am thinking to take the class more, but my health is not good. Okay, so no issue, we will start tomorrow. After this chapter will be finished, you will get the complete note. And one more thing, that you have to do hard work, and you have to be regularly, you have to solve each and everything and revise each and everything. We are bringing this for you only, and in return of that you have to do nothing. You have to just share this to as much as number of students, so that who has need of this thing, they can get this thing, and they can do their preparation in good manner, and they can also do their studies in proper manner. Just you have to do that. Okay, so please like this session, subscribe, and try to share as much as for it is possible, because we are doing this for you only. Okay, so thank you and have a nice day, and just take care.